powered MCU, IoT product development for wearable applications, flexible electronics applications and shortcomings, serverless IoT architectures for wearable computing. The FDP will be conducted from 11th to 15th January 2021 with three sessions on each day. The honorable speakers of the coming three sessions are Mr. Damodra MS, Business Head of Enterprise Technologies, Bengaluru, who will be the speaker on the topic IoT and wearable devices design considerations. Dr. Sumit Kalra, Assistant Professor, IoT Jodhpur, Rajasthan, who will be the speaker on wearable. The FTP will be conducted from 11th to 15th January 2021 with the three sessions on each day. The honorable speakers of the coming three sessions are Mr. Damodra MS, Business Head of Enterprise Technologies, Bengaluru, who will be the speaker on the topic IoT and wearable devices design considerations. Dr. Sumit Kalra, Assistant Professor, IIT Jodhpur, Rajasthan, who will be the speaker on wearables for healthcare IoT-driven telemedicine. Dr. Tushar Kanti Bera, Assistant Professor, Department of Electrical Engineering. Welcome all to the inaugural ceremony of the AICTE ATAL Academy sponsored 5 days online faculty development program on the topic IoT for wearable devices from 11th to 15th January 2021, organized by the Electronics and Communication Department of Sengit's College of Engineering. This is the first online FDP sponsored by AICTE Training and Learning Academy conducted by the Department of Electronics and Communication. At the outset, I welcome Mr. Damodra MS, the Business Head of Enterprise Technologies, Bengaluru, who will be inaugurating the ceremony and delivering the inaugural address. Next, I welcome Professor Dr. Joseph Kunyupolsi, the Principal of Sengit's College of Engineering, to the ceremony. I also welcome Dr. Ruboy Cherian, Professor and Head of the Department of Electronics Engineering and the Coordinator. Now, let's invoke the blessings of the Almighty by a silent prayer. Now I invite Dr. Ruboy Cherian, Professor and Head of the Department of Electronics Engineering, Sengit's College of Engineering, to welcome the gathering. Over to you, sir.
Thank you. Very warm good morning to one and all. Respected President of the function, Joseph Kunyupolsi, Principal, Sengit's College of Engineering. Our guest of honor, Damodra MS, Business Head, Enterprise Technologies, Bengaluru. Participants from various colleges from different states of India. The coordinators of the FDP, Dr. Ansel K. and Engineer Abraham J. Thomas, and my dear colleagues, a very warm good morning to you all. In this pandemic situation, so we know, because it's actually a FDP sponsored by ATAL, AICTE ATAL Academy, and this is the first online FDP conducted by our department, Department of Electronics Engineering, and this is it's an online FDP. So regularly, our department is organizing various international conferences and faculty development programs for sharing and learning new things from various experts. So actually, this is a platform for gathering and learning so many new developments in the technology, electronics technology. That is basically, and this FDP is based on IoT devices for IoT for wearable devices, and it's actually 5 days FDP. That is from 11th to 15th. And I hope we are blessed with a very good technical experts in the field of this IoT for wearable devices, and we are going to explore the outcomes from all this. I am sure you will be getting a lot of information from this technical experts within the coming 4 days. So the duty imposed on me is to welcome you all to the inaugural ceremony of the ACT ACT Adult sponsored by Adult Academy, 5-day FDP on IoT for wearable devices. Here, Dr. Joseph Kunipal C. He accepted our invitation, and he's ready to preside this inaugural ceremony of our FDP. So, on behalf of Department of Electronics Engineering and my own behalf, I totally welcome you, sir, to this inaugural function. Welcome, sir. Next, I invite Engineer Mr. Damodara MS, Business Independent Technologies, Bangalore. He is also associating with us for the past 10 years. That is having MOU with Independent Technologies, and he's an expert in the field of IoT devices, and its design aspects. In spite of his busy schedule, he accepted our invitation and ready to deliver a keynote address on today's FDP, and he's also ready to inaugurate our function. So on behalf of all of us, I totally welcome you, sir, to the inaugural ceremony of this FDP. Welcome you, sir. So next I welcome the various participants from various states of India. So we got a lot of entries from engineering colleges in and around the state and all over different states of India. And participants are the best, more important for the success of any event. So today we have with us the participants from more than 10 states in India. And on behalf of the Department of Electronics, I totally welcome all the participants to the inaugural function of the FDP on IoT for wearable devices. Welcome you all. So I take this opportunity to congratulate and thank the coordinators of our FDP, Dr. Ansel K. and Engineer Abraham K. Thomas. So they started their work more than 2 months before, because we proposed a plan for ACT for this FDP, and we got sanctions for conducting the FDP by the Adult Academy of ACT. So I take this opportunity to thank the coordinators for their efforts for bringing this FDP in this level. So last but not the least, I welcome all my dear colleagues to the inaugural ceremony of our FDP on IoT for wearable devices. So I hope all of you can learn so many new things related to the Internet of Things. That's a recent research trends in the field of electronics, and hope all of you will have a fruitful 5 days ahead. So once again, I welcome you all to the inaugural ceremony of our FDP. Thank you all.
Thank you, sir. Now I invite Mr. Damodara MS, the Business Head of Entupal Technologies, Bengaluru, to officially inaugurate the AICTE Training and Learning Academy sponsored 5 days online faculty development program on IoT for wearable devices and to deliver the inaugural address. Over to you, sir.
Thank you, madam. Yeah, very good morning to all the members on this online platform with us. On behalf of Entupal Technologies and St. Gitt's, I welcome all of you for this faculty development program. The technology of IoT, as all of you are aware, okay, right, has seen its evolution, okay, right, over the last several years. But many of us, we believe that IoT has come into the foray, okay, only in the last 5 to 6 years, but it is not actually the scenario. In fact, IoT as a technology has its roots, okay, right, more than 15 to 18 years, okay. In fact, as a practicing engineer, I heard about a technology which is very much in similar lines with IoT in the year 2004 and 5, okay, when I was working with an Nortel, okay, right, and as well as Cisco teams, okay, right, as a project engineer, okay, during those times with my team. There was a technology by name unified communication. I don't know how many of you are aware about that technology. So unified communication actually laid the foundation for the IoT, what we are seeing today. So in fact, unified communication actually brought in the concepts of, right, seamless communication and seamless access of information, what basically the fundamental philosophy of IoT. And unified communication framework was also promoted by some of the industry leaders like Cisco, Juniper, Avaya, and as well as Microsoft, IBM, and many other industry leaders. They promoted this, and this came into picture. Even actually, Google came into existence. In fact, as all of you know that Google is only about 14 years as a technology giant, okay, right, 14 to 15 years. But even before Google existence came into picture, the concepts of unified communication was very much there. So then what unified communication was talking about, unified communication was primarily referring to the seamless communication and seamless exchange of information. For example, if I'm an end user, okay, right, who is making a GSM call, okay, right, and when I'm taking up that call from my home, during those days, the technology of voice over IP was very much existence. So as soon as I make a call from my home, and if my home is powered with internet, then the call transfer happens from my GSM to the data network, okay, at my home. The moment I step out of, the moment we step out of the home, then the call transfer happens between the home internet access to the GSM network, right? And from the GSM network, okay, right, as soon as we move into our work environment, that may be our college campus, or else that may be an industrial environment, immediately the call transfer should happen between the GSM network to the data network of the proprietary, right, system. So that is what is the concept of unified communication. So why all these technology giants were so interested in the unified communication during those days was that people were very much adapting to the concepts of VoIP in medical industry and in automation industry and various other segments. So they saw that integration of the GSM technology with GSM technology with other things will also have a lot of benefits. So with that viewpoint, these technology giants, they saw that, right, this can be a revolutionary thing. But why, then you may have a question in your mind that why unified communication never became a well adopted technology across the globe. The reason for that was very simple. The internet penetration was the primary reason why the technology never flourished as per the expectation, and later subsequently the everybody waited for the internet penetration, and now thanks to the internet penetration now the entire communication is now totally relying upon internet, in fact. So that is what laid the foundation for internet of things or internet of everything, in fact, what we are seeing today. And today IoT as a technology is very, very pervasive, right? And it is showing the new avenues of the business, and it is showing a lot of unexplored territory for us, okay, right, across the globe, be it medical healthcare, which is the most sought after thing today in the midst of all this pandemic, and plus further even in automation and various other segments, it is having its pervasiveness increasing day by day. One of the report of Gartner in 2001, it said that on a daily basis, nearly around 32 electronic gadgets touches the normal human life. But today, just about in 2017 and 18, Gartner again released another report, and it said that more than 200 electronic gadgets touches our life today. That basically talks it volumes about the penetration of electronics and the penetration of IoT as a technology among us today. So as a result, it is important for us to understand that how this technology, it is really, really pervasive for us. And further, each and every branch of engineering, they have their own role to play in IoT as a technology. If students and research scholars and faculties from electronics department, computers, mechanical, and other streams, if they are working in tandem with each other, it is very important that each one of them, they have their role to play. So with that note, I would strongly recommend that whether you are from electronic stream, whether you are from mechanical or IT branch, or even from any other stream of engineering, right? IoT as a technology has your element and your contribution also. Without your contribution, this technology, it won't run. So as a result, you stay connected to that part of your contribution in the IoT as a technology really plays a very, very important role, right? So with that note, I wish this program is going to be a very, very productive exercise for all the participants. And I also take this opportunity to thank Department of Electronics and Communication Engineering, St. Gates, okay, right, for bringing this kind of a program for the academia network pan India in this challenging times. So I wish a productive learning, okay, from this program for all of you. Thank you. Thanks for this opportunity.
Thank you, sir. Now I invite Professor Dr. Joseph Kunyumbol C., the Principal of St. Kitts College of Engineering, to address the gathering. Over to you, sir.
Chief guest of the program, Sri Damodar Das MS, Business Head, Interpol Technologies, Bengaluru. Head of Department Electronics Engineering, Dr. Iboy Cherian. Coordinators of the program, Dr. Ansel K. and Abraham K. Thomas. Resource persons, delegates, faculty members, and dear students. A very fine good morning to all of you. Damodar MS has already mentioned the main applications and advantages of IoT related to wearable devices. But as far as a mechanical engineer I am concerned, I don't have much knowledge about the IoT and the wearable devices and the synchronization regarding everything. But as you know, one of the emerging streams in computer science is, of course, IoT. And regarded with the concerned with other very emerging fields in computer science like artificial intelligence, cloud computing, etc. IoT can be regarded as a versatile stream because IoT may be the main technology which has made inroads into every aspect of life, whether it is industry, domestic applications, or even personal applications, whatever may be. So IoT stands high considered to among other various emerging streams of computer science. And the wearable devices has been in use from very long past, like pacemakers, etc. But the difference is that when the wearable devices is used, they don't have any facility for monitoring the various things that is going on in the respective field like that. And when the wearable devices has been synchronized with IoT, we have got the opportunity to monitor everything that is wearable devices is incorporated, attached to a human body. We can easily monitor the various aspects like breathing, oxygen, level of oxygen in the blood, perspiration, pressure, etc. Various things can be monitored for health conditions, and for even other aspects, depending upon our requirement. The criteria which has to be monitored by the authority can be monitored by means of wearable devices. Of late, in this pandemic period, many patients may be finding it difficult to visit the doctors, visit the hospitals, visit the laboratories, etc. And again, the laboratories or the hospitals may be restricted or finding it difficult to give consultancy to old age patients, like all those things. And in this arena, the wearable devices, which is provided with a suitable monitoring things, with the parameters which have to be monitored are provided, we can easily, the doctors or the relevant persons can easily monitor what is going on, what are the changes that is going on. And once the patient is staying at home and the doctor may be aware, maybe at a far off place, even in the hospital, and he can easily monitor those things and prescribe the necessary preventive measures. And another advantage is that what I think, usually for advanced treatment, people used to visit the UK, America, etc. for advanced treatment and everything. Now with the wearable devices and IoT is synchronized with the wearable devices, even I think I hope I may be right. The doctors are sitting at far off places like UK and United States of America can monitor these things and they prescribe the medication that can be applied to the patients. In all these things, it has got a far-reaching effect. And this will bring a revolution in the medical field, of course. And this area is a developing area, and I think there's an ample scope for research in that particular area. And the main advantage of this research work is that it will be mainly concentrated on something that is doing something to the society, and is, of course, bearing on the society, and you can do something which will be directly contributing to society, which is one of our main objectives of outcome-based education, that will be satisfied. And as a practicing engineers, we should be exposed to this field, the latest field that is going on, especially something related to medical field. Even otherwise, electronic engineers has got a strong relation between medical field, like biomedical engineering, etc. Maybe elective or maybe a subject for electronics engineering. And now that this IoT and wearable devices has been come up, there is ample scope for research, and you have to utilize this possibility. And you should be, at least you should be aware of the things that is going on with the wearable devices and IoT. And the ATAL program was kind enough to sanction an FDP in these emerging areas, which will be having direct benefit on the society. And let me take this opportunity to thank the ATAL Academy for sanctioning an FDP based on this having a wearable effect on the society. And I also appreciate the electronics department of our college, especially the coordinators, Dr. Ansel K. and Abraham K. Thomas, in organizing a FDP on a program which is very much relevant today. And I hope The participants will be really benefited by this program, and I wish the program more success. Thank you.
Thank you, sir. Now I invite the coordinator of the FDP, Dr. Ansel K.A., Associate Professor, Department of Electronics Engineering, St. Kitts, to propose the vote of thanks. Over to you, sir.
Am I audible, Chippy?
Yes, sir.
Yeah. So it's a very warm good morning to all gathered to participate in ACT ATAL Academy sponsored 5-day online FTP on IoT for wearable devices. Here we are giving more emphasis on the program as we explore the potential of wearable devices integrated with IoT. So my assignment is to give a vote of thanks for the inaugural ceremony. So first of all, I thank the ATAL Academy and the ACT to sponsor this online FTP for 5 days for IoT for wearable devices so that the board exposure could be accessible to all the faculties and the postgraduate students through versatile sessions of experienced speakers from academics as well as industry across the nation. On the behalf of India team behind this FTP and St. Kitts family, I express my sincere gratitude to the Mr. Damodara MS, who is the business head of N2P Technologies Bangalore, who inaugurated this online FTP and gave us an insightful inaugural address. Thank you, sir. I also thank the St. Kitts family, especially Sri Thomas T. John, the director of St. Kitts Group of Institution, and Engineer Punus George, the executive chairman of St. Kitts Group of Institution. Because of some issues, they are not able to join with us. I thank them, especially without the aid and support of them, this online FDP would not have seen the light. Thank you all for taking time and take part in this inaugural session and your wholehearted support towards the success of this FDP. Next, I would like to thank Dr. Rabu Charian, the head of the Department, Electronics and Communication Engineering, welcoming in this inaugural ceremony. Thank you, sir. Bringing up Dreyer, I would like to extend my profound recognition and appreciation to all the participants who joined in the inaugural ceremony in spite of the hardship around us. So once again, I thank you all for this session and happy learning. Thank you all.
Thank you, sir. Now we will wind up the inaugural ceremony with the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय जय हे जय 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 हे
Thank you, everyone. The inaugural session has been over. Now we will be moving on to the first session of 11th January 2021. There are some general instructions to the attendees. Please mute your mic and turn off your camera during the session. Please fill the feedback form shared after each session. You have to complete the feedback form within 10 minutes after the session. There will be a separate QA session. Participants can turn on their mic to ask their queries. Kindly join 5 minutes prior to the session. The instructions on the final test and issuance of certificates are: a test shall be conducted by the coordinator at the end of the program. The certificate shall be issued to those participants who have attended the program with minimum 80% of attendance and scored minimum 60% of marks in the test. Good morning to all present here to attend the AICT ATAL Academy sponsored 5 days online faculty development program on the topic IoT for wearable devices from 11th to 15th January 2021, organized by the Electronics Department of St. Kitts College of Engineering. IoT and wearable devices design considerations. The speaker for this first session is Mr. Damodra MS, the business head of Entipal Technologies, Bengaluru. I take this occasion to welcome everyone to this session and thank you all for being here amid the pandemic situation we encounter at present. Before moving on to the session, I invite Ms. Chinju S. Ragamaliga to introduce our guest speaker. Over to you, Chinju.
Thank you, Chippy. Am I audible?
Yes, you're audible.
A very good morning to everyone. First of all, I welcome each and everyone to the 5-day online FDP on IoT for wearable devices, sponsored by AICT Training and Learning Academy, organized by the Department of Electronics Engineering, St. Kitts. Today, we have Mr. Damodra MS to speak on the topic IoT and wearable devices design considerations. So before that, let me introduce our guest to everyone. Mr. Damodra MS is currently the business head at Entipal Technologies, Bengaluru, India. He is primarily responsible for application engineering and consultation for customers across India from defense, aerospace, and corporate sector. Prior to joining Entipal Technologies, he was with IEEE as product manager. At IEEE, he was contributing as an industry liaison to semiconductor industry. He was actively involved in IEEE Standards Association activities supporting System Verilog and UPF work groups. He also supported a new learning initiative from IEEE Blended Learning Program. He received Appreciation Award from IEEE President for his contribution for proliferation of St. Kitts and learning activities. Damodara carries 17 years of industry experience with core expertise in front-end design and verification, broad system design with experience in telecom equipment, medical systems, aerospace automation, and automotive hardware system design. Throughout his career, he supported educational and competency building activities. He contributed in developing learning solutions in the space of RTL design, verification, timing analysis, system design, and more as a subject matter expert. He received Appreciation Award for his contribution in competency building initiatives for internal engineering resources at Wipro Technologies. Currently, he is supporting IEEE in education activities. He is actively assisting Electronic Sector Skill Council of India in developing national skill qualification framework for engineering job profiles in VLSI domain that include design and verification engineer, system design engineer, and more. So on behalf of St. Gates, I welcome Mr. Damodara MS, Business Head, Entipal Technologies, to the 5-day online FDP on IoT for wearable devices, sponsored by AICTE ATAL. Over to you, sir.
Thank you, madam. Can you enable screen share, madam, so that I can share my presentation?
Yes, sir, please wait.
Yes, sir. You can share your screen, sir.
Yeah, thank you.
Yes. I kindly request all the participants to mute your mic and mute your videos.
Hope my screen is visible, madam.
Yeah, sir. Yeah, sir. Your screen is visible.
Yeah, very good morning to all the participants and faculty members and the team of St. Gates College of Engineering. Okay, for this first session of this faculty development program. And before me beginning with the proceedings, okay, right? I take this opportunity to convey my new year wishes to all the participants. So I wish year being a productive one for all of you. So please follow the ground instructions, okay, for the productive interactions over the next 1 hour. So keep your mic on mute and turn off your video throughout the session, and share your questions in the chat box, and all your questions shall be answered in the QA session. So the topic which I'm going to be addressing is IoT and the wearable devices, the design considerations. When we are talking about design considerations, I'm going to be emphasizing more on the hardware design considerations, because today IoT as a technology, right, it has multiple layers. So I'm definitely going to be throwing light on those different layers of an IoT system. And at the same time, I'm going to be emphasizing more on what is the design considerations for the sensors, and as well as actuators, and as well as the node MCUs and the processing units, which are critical components in an IoT system. And plus, uh, we are also going to be different network uh, protocols, right, which are very much relevant for the different applications. Remember, IoT as a technology has pervasiveness in different applications. So depending upon the application, you will see different types of communication protocols being in use. So as a result, when a researcher or even a student starts working on a project ideation or else project concept for IoT related application, it is very much important for them to understand that what are the components which they are using, and what kind of a protocols which they are using for the given set of application. Today's session, okay, right, we are going to be addressing the design considerations for the hardware and the protocols which are very much in use in different applications. That is what we are going to be discussing in today's session. Outside the scope of this, if you have any questions, right, related to IoT aspects, you are most welcome to share those things. I'll try to answer that. So to begin with, Entupal, we are a design services and a product and IP development organization with a 10-year young background. Okay, right? And today we have our presence in multiple engineering verticals like VLSI and electronic system design, RF, and mechanical structures, computational fluid dynamics, and renewable energy systems, to name a few. And we also have our presence in emerging technology verticals like IoT and cyber security, right? Also, in all these technology verticals, we cater to defense, aerospace, and as well as mid-market segment, and as well as multinational clients and customers of ours. And we also provide design services, product development, and simulation solutions, okay, for our customers. And we also have a dedicated wing which works with academic network across India, known as EASY, Entupal Academia Solutions Initiative. So through that window, whatever the learning outcome which we gain from our corporate and as well as product delivery experience, we come and share, okay, right, our experiences with the academia network. And in fact, as a part of that effort only, right, I'm with all of you here, in fact. So the domains where we carry our strong specialization are being shown here. So here you have the major verticals like mechanical and computational fluid dynamics, right, on the mechanical engineering segment. And similarly, on electronics side, we have electronic system design and PCB design and semiconductors, right, are the segments what we have, where we have our presence. And on electrical engineering segment, okay, right, we have our presence in power electronics and as well as e-mobility, right. And on the communication side, RF solutions and as well as high performance test and measurements. And on the emerging technologies, we are actively having our presence in IoT, cybersecurity, 3D printing, and as well as PCB prototyping and testing. So these are the broader technology domains where Intupal as an organization, we carry our expertise and our presence. So these are the broader business units, okay, right, which are present within Intupal. CAE stands for Computer Aided Engineering, is one vertical under which we provide turnkey simulation solutions and as well as design services and consulting for our customers. Then Intupal Products Division, where we work on our own products and IP solutions for our customers and clients. And we also provide design services solutions for our customers in all the technology verticals which I mentioned. And apart from that, we also do address the training and development activities, okay, right, and services for the defense, aerospace, multinational clients and customers of ours, and as well as academic community across India and worldwide. And we have EASY, Intupal Academia Solutions Initiative, which interacts with academic network pan India, in fact. So the major market segments where we have our presence include aerospace, defense, PSUs and automotives, and R&D customers of ours. Then we also have training solutions, which goes on-site and as well as online mode from our end. So this is the pan-India presence of Intupal as an organization. Today, we are a 135 plus employee organization with pan-India presence. Okay, and we are in all the technology verticals which I mentioned earlier, right? We are associated and we are working with right in a mutually right a collaborative partnerships with all these technology leaders. Now, coming specifically into today's topic of the discussion, IoT, as all of us, we are aware, it is a seamless connected world, what we are talking about today. So in my earlier keynote, inaugural note, I mentioned about how the IoT as a technology has evolved over the years. Okay, so be aware that it is the internet adoption which has made all the difference for the like IoT as a technology, people call it as, right, it is a extended technology or else it is a extended right outcome of legacy technologies like wireless sensor networks and classic embedded systems and computer networks, right? So, and automation. So all these four components, if you put together, but IoT. So as a result, IoT as a technology, as I was mentioning, when you look back at the history in 2004 and 5, people were talking about unified communication, but later you took the right acceleration for the simple reason of internet penetration, because internet penetration was not that extensive till the last decade, that is 2011-12 onwards only. the internet penetration started to happen more and more. So as a result, the IoT as a technology today, you see its presence in wearable technology, healthcare, and smart appliances. So it is very much right between us as a technology. So you don't see right IoT right as a future technology today. It is very much a technology right which is driving our day-to-day life today, because even automotive systems are powered up with internet, and they are also connected to right both active and passive systems. So hence IoT as a technology, it is a seamless connected world today. In fact. So when we are talking about IoT, it is not only few devices and gadgets which are connected, being connected with each other. There are more than that. Okay, for example, you can see a couple of examples in front of you, right? A lady getting ready for her right a daily routine. You can see her that she's using a smart mirror where she not only getting ready for right herself, she is also taking a look at her right daily schedules and watching the right the news, okay, right, just to get to know that the news and updates from across the globe. So as a result, something like this, which we call it as a smart mirror, is already being implemented in smart homes by many right reputed real estate right players within India and across the globe, right? In fact, so as a result, IoT as a technology for seamless connectivity in smart homes, it is already there. And at the same time, if we look at microwave oven today, right, there is a microwave oven option which you can control from your office or else from your workspace wherever you are, right, so that automatically you can control the gadgets. So that facility is already available to you. And take a look at the washing machine. So if you want to control how much should be the soaking period, how much should be the dry spin, and how much should be the wet wash, and those different kind of options. Earlier, if you want to control, right, you need to select all those options manually using the keys, right, being at home. Now today you don't have that problem at all. If you want to control those operations, okay, from your workspace, from your travel, or wherever you are, you can very much do that. And at the same time, coffee vending machine which you are seeing in front of you, right? So the entire mechanism under which the coffee vending machine or else any consumable service works today, it is completely changed. For example, I am going to show you, right, some of the success stories of IoT as a technology in the coming minutes. Because today, right, even a coffee vending machine is connected to internet. Then you may wonder that why a coffee vending machine has to be connected to internet, because there is a business sense and business purpose why the coffee vending machine has to be connected to internet, right? And similarly, a weighing scale, even a weighing scale in right in gym and as well as in medical facilities, right, are connected to internet. Then you may wonder that why even those gadgets are connected to internet, because the useful information what they acquire will act as an input for some other business. So as a result, the long before all this information was seemingly going unnoticed. For example, if we take a coffee vending machine, then that coffee vending machine may have different flavors like cappuccino, frappe, and different options, right? Then in a given facility, if this coffee vending machine is being installed, that particular community there, they may be preferring only espresso or cappuccino or frappe or specific flavors of the coffee according to their taste and their liking. Then the coffee service provider, maybe Cafe Coffee Day or Barista or else even right Starbucks, they want to attract our own chai point. They want to know that what is the consumption pattern, and so that they can refill the commodities according to the consumption pattern, so that they don't lose a customer, they don't lose the consumption uninterruptedly. So that is how today, as a technology, even consumer services like coffee vending machine, right, seeing a value proposition in IoT as a technology. So what is that means for you and me? That means more things are now being connected to the internet ever before, and it is going to continue now. Okay, right? So that is what IoT as a technology. And IoT technology is not just about machines and gadgets are connected to the internet. It is more than that. Why I'm saying more than that? Let us take a look at the symbol of human in front of you. Today, most of us, we carry a Fitbit, we carry a smartphone, and we carry even a smart handheld device and spectacles and whatnot. So we have ECG sensor, motion sensor, and so many other gadgets which are connected to us. So all that sensors, they will be acquiring lot of data from our human body, maybe ECG pattern of our heart, and the sweat conditions of our body, right, and glucose levels in the body, and so many other parameters are getting captured by these sensors, and that information will be fed to the smartphone. If they are all connected to your smartphone through the applications or apps which are running in your smartphone, then all that data which is collected by those applications or apps will be storing the data, and that data is getting stored in your smartphone, and that data in turn it is also stored in the internet, and that information may be going to your health service provider and for your own medical records, and it also may be going to your near and dear ones. So if you look at the overall scheme of things today, it is people are also connected to the things, right? So that is how the scenario is. Now, it is not people, it is things also connected to the things. So for example, if you look at a police surveillance vehicle, right, or else an automotive which is running on the road today, they are all connected with each other through IoT, because even automotives, they are enabled with GPS navigation, they are also enabled with IoT. So they are also enabled with internet access. For example, you might have seen the ads of Morrison Garage Hector. So it has internet enabled vehicle. So similarly, there are a lot of vehicles from Honda and as well as even Volkswagen and lot of other automotive leaders where you have internet access. So what is that means? That means those automotives, they are connected to the other vehicles, right, and they are also connected to the internet. They are also connected to the so many other components which are part of the system. So as a result, it is a very complex and heterogeneous networks and the resources what we are seeing in front of us because of IoT technology. Continuing further, as I earlier mentioned, IoT as a technology has its roots, okay, right, from various other technologies. For example, the very first one is wireless sensor networks. So if you look at the classic wireless sensor networks, the classic wireless sensor networks was talking about, different uh, wireless terminals acquiring the data from their proximity and the vicinity, and all that data given to a local host computer. That is what they were doing. But today, because of the increase in the number of sensors around us, what is really happening is that those different sensors which are acquiring lot of data, all of them, they are not connected to the host computer directly. Instead of that, they are connected to a node, computing node, which basically acquires the data, and that several such nodes which acquires the data from the different types of sensors, they in turn connected to the gateway, because the node can acquire the data or control the communication between, right, themselves and small sensors. But the gateway has the capability to drive multiple nodes and plus also handle large amount of data traffic. Remember, the nodes will not have that capacity, whereas the gateways will have the capacity to handle large data traffic. So if you are connecting some n number of nodes, okay, to your gateway, then each node will be pumping certain volume of data into your gateway, and your gateway has a bigger data, right, a traffic management capacity, and hence it acquires and it sends all of the data, sometimes maybe pre-processed data, sometimes, right, it also does the data processing, and then it gives the data to the cloud. So the cloud is a place where all the data is going to be, right, stored, and it also will be put through a lot of analysis, and then that analyzed data will draw a lot of conclusions, which we call it as data analytics, and that information will be sent back to the gateway, and in turn it will be sent back to the node and the sensors and the actuators which are present at the grassroots level. So this is how the classic wireless sensor networks laid the foundation for the IoT technology, what we are seeing in front of us. The only differentiator is, in terms of the wireless sensor networks, what we had about 20 plus years back, and the IoT today is, the wireless sensor networks were only talking about the sensors which are in turn connected to a computing node. Whereas IoT, right, is basically an extended version of it, which brings in a couple of other components like gateway and the cloud and the analytics, right, and other components, in fact. So that is how wireless sensor networks has extended into IoT technology, what we are seeing in front of us. Now, how these networks are changing? These networks, as you saw in the previous slide, they are continuously having extensions. So that means more number of nodes, more connections, and each one of these connections, they have their own, right, connectivity technologies running in within them. For example, there may be Bluetooth, Wi-Fi, or else Zigbee, right, or internet protocol versions v6 or low GPON. So different connectivity technologies are actually connecting them together. So that means we are literally talking about anytime, any place, and anything which are continuously connected with each other. Then not only that, machine to machine, right, and IoT connectivity talks about billions of interconnected devices across the globe, and everybody is also connected in this framework. And the expansion also includes broadband, and the enhancement includes smart networks, data centric and content oriented networking, and context aware systems. When the extensions are happening today in an IoT system, that extension and the connectivity, it is data centric and content oriented networking also. For example, if you are getting connected to, right, an automotive service provider today, only when you are in need of a commutation requirement, that means it is, right, oriented networking what you are getting connected to. And at the same time, data centric, when you are connecting to any specific application today, okay, apps, it is all driven by your data requirement. Whether are you looking for a, right, a food service provider, are you looking for, right, an automotive service provider, or else are you looking for, right, some utility services. So as a result, the data enhancements what you may seek from your end as an end user, it is data centric. And as a result, the IoT technology, right, framework also today basically supports those things, where it is either data centric and content oriented networking also, and at the same time context aware systems, where the systems which are seamlessly connected with each other, they are autonomous, and at the same time they can seamlessly interact with each other, in fact. So this is how the networks are changing, right, in our day-to-day life, in fact. So what is going to be the future of the networks, if this is the way we continue to move forward in the coming days? Remember, already we are seeing anytime connection, any place connection, and anything connection. So with all these three parameters, couple of things are really becoming more and more important. That is, any time connection, that means during day or night time, you want to have seamless connection, and on the move, and indoors and outdoors also. Any place connection, which includes on the move, indoor and outdoors, right? And at the PC, right? With the help of your smartphone, tab. So you want connectivity at any place according to your choice and your preferences, and anything connection. So today you want your smartphone, your tablet, your PC, your gadgets in your home like washing machine, microwave oven, right? And lot of other devices, you want them to be connected to the internet so that you can manage them or else you can control them seamlessly. So as a result, right, the future of the networks is going to be so different that literally you will end up seeing any other system or gadget which we are going to be using very much is going to be connected to the internet, so that you can remotely control and remotely monitor those gadgets. That is how the networks are evolving. But when things are exploding in such a exponential manner, but at the grassroots level, couple of fundamental aspects still remains the same. So if you look at the key blocks of an IoT system, it is very important for us to understand that what is the design considerations which are actually driving them. So let us try to understand that little bit in detail. So here, when it comes to the key blocks of an IoT system, the key components are the sensors, right, which acquire a lot of data from the surroundings and from the atmosphere around us. And then those sensors in turn feed that data to the computing terminals. It may be a microprocessor, it may be a microcontroller, it may be a digital signal processor or FPGA. Remember, the compute node, right? Generally, the perception what we carry is that it is a microcontroller. But my suggestion to all of you is that it need not have to be a microcontroller all the time. You may be using a Node MCU, you may be using an Arduino, or else you may be using Raspberry Pi, or else you may be using an FPGA, or right hardware powered with Intel processor. But if you look at all of them, eventually all those computing nodes, they basically acquiring the information from the sensors, right, which are connected to them. So as a result, the IoT system, when we are talking about compute, generally this is one of the misconception which I have seen in students, right, that they believe that the IoT systems are only made up of, right, microcontrollers. It is partially true, but it is not complete, because today you have IoT systems. For example, the broadcast cameras or broadcasting systems, they are enabled with a DSP and digital signal processors, and they are also part of your IoT today. And at the same time, the surveillance, right, cameras which are running in our highways or else which may be running in our homes, they also have a digital signal processor, right? So, and FPGAs also. So as a result, the compute node, what we talk about, it may be made up of a microcontroller, microprocessor, FPGA, or digital signal processor. Now, apart from compute node, we also have a connectivity, right? When the information is flowing from the sensor to your compute node and from the compute node to your cloud, right, or else from the cloud back to your, right, sensors and the actuators which need to be driven by the data analytics, then there is a seamless connectivity which is running between all these three layers. So in broad terms, we can say that the key blocks of an IoT system is sensors and the computing nodes and the connectivity, right? So these are the three important ingredients of an IoT system. Now, Now, if these are the IoT components, okay, right, then what are the design considerations which we should be aware about as far as the design of these components is concerned? As I said, the focus of today's session is more on what are the design considerations for the electronic systems which are part of IoT. Then the first and foremost thing which all of you need to be aware about is that what are the components, what are the electronic components which are part of an IoT. As I mentioned earlier in the previous slide which you saw, the sensors. The sensors may be a temperature sensor, light sensor, gas sensor, different types of sensors, and different types of motor, driver controllers, relays, and all of that. So they are actuators for you. So, and at the same time, you have your computing cores like microcontroller, microprocessor, DSP, and even FPGAs. They are also hardware for you. And on top of that, you also have lot of connectivity chipsets which are part of your IoT. So all of these elements forms your electronic part of your IoT, or else electronic system part of your IoT. Now the question is that when we are building any one of these components, or else when we are choosing any one of these components for our IoT system, remember, design and manufacturing of these individual components is one part, whereas using all of them and building an IoT system is another part. But in both the aspects, what is important is that what is the design considerations which goes in making either those discrete components or making the entire system. So what are the requirements which we are talking about? Let us understand a little bit more about that. We are looking for the need of sophisticated mixed signal verification tools uh, which allows us to tie to the system level tools for what is that means? That means when you are designing a sensor, maybe from the device physics level, or else when you are building, right, building an electronic system which is part of the IoT, in both the cases, important is that the tools which you are using either to build a sensor, I mean sensor model, or else either to build an electronic system which has a right sensor and the actuator, the most important thing for you is that the tools which you are using for the design and modeling and the tools which you are using it for the entire electronic system design should be supported with mixed signal verification. Then why mixed signal verification? It is very important for you to be aware is that, for example, if you take a sensor, right, at the transistor level or else at the device level, then the transistors will be acquiring the signal from the surrounding environment where the data is analogous in nature. Once the data is acquired by that sensor device or sensor materials, then the data need to be converted into digital format, because once we acquire the data, all the data processing happens in digital format. So hence it is very important that the simulation environment and as well as hardware design environment should be enabled with mixed signal verification tools. That means the tools what you are going to be using, the tool should support you mixed signal design at lowest level of abstraction, such as circuits and integrated components, integrated circuits, okay, right? And at the same time, that same mixed signal verification capability should also be there in the electronic system design tools also. So this is one of the very, very important requirement in, right, design and modeling of hardware for IoT applications. Because if you are working with a tool which doesn't have the mixed signal capability or else mixed signal verification, then you cannot thoroughly verify your hardware, or else you cannot thoroughly verify your system which has to support IoT application. Then downsizing of the connection and the technology costs. So depending upon your requirements, you should be able to downsize the type of the connections and the connectivities which you want to address. Sometimes Bluetooth may serve your purpose, or Zigbee or Wi-Fi. Sometimes you don't need all three, and at the same time there may be some applications where you need all three connections, right? Then significant increase in the devices with the built-in Wi-Fi and sensors with smartphone usage. So today, if you are talking about even, right, a gas sensor, that gas sensor comes with built-in Wi-Fi, right? And at the same time, if you talk about, right, a temperature sensor or different types of sensors, each one of them, they come with a built-in Wi-Fi, so that they can pump the data seamlessly into your other terminals, which makes your task much more easier for you. So those are that means if you are building a sensor today, the first and foremost requirement is that, are you bringing the connectivity also to that sensor? So that is a kind of a requirements, design requirements we are heavily coming across today in our, right, different applications and different product solutions what we are building for the IoT systems. In fact, continuing further, the design requirements are getting more and more complex. In IoT devices, power is very critical, since the devices need to run for days, weeks, and months. So that means those devices, they need to be power efficient. So when I say they need to be power efficient, remember, when you are building your integrated circuits for IoT applications, when you are building hardware, electronic hardware for the IoT applications, you need to keep in mind. So when you are building your integrated circuit, when you are building your electronic system, you always need to ensure that you are doing the power analysis also. That means power budgeting. How much amount of power individual sensor and individual node and the gateway consumes, and what is the overall power requirement of the system, you need to identify well in advance. In a very early stages of the design life cycle, you need to, right, capture this information, because this will decide the performance of your IoT products when it actually goes into the market. Because nobody prefers a smartphone which demands charging every 3 hours, isn't it? Similarly, nobody prefers an IoT product which is power hungry. So as a result, when you are building an IoT hardware, you need to ensure that the devices are power efficient. Then mixed signal challenges. The mixed signal designs continue to throw a lot of challenges for us. For example, analog to digital data integration. When the data is moving from the real life environment to any computational environment, the data moves from analog format to digital format. So there is going to be a data converter which converts the analog data to digital format. But still, there will be issues like interface, communication standards, and the combination of sensors that systems, right, are made up of, and the complexity between them. And at the same time, RF wireless, digital microcontrollers, right, and the packaging and the board. So when you are dealing with, right, all these systems, you need to ensure that whether you have the mixed signal ready-made IP cores or mixed signal, right, blocks, which helps you to manage the data transfer, okay, from one terminal to another terminal. Now, the design form factor limitations. Remember, all the IoT gadgets, what you are seeing, whether it is sensor, node, gateway, or the cloud, you want all those devices should be, right, very small in size, right, power efficient and area efficient also. So as a result, IoT products are driven by the need of for the smallest form factor, that means small dimensions. So that is one of the requirement of all the wearable devices. So you cannot think of having a huge, right, Fitbit which nobody buys. So then the size of the Fitbit has to be very small. This is where exactly the mechanical engineering design also plays a very, very important role. Remember, right, when you are, right, building a hardware, you also need to pay attention to the mechanical dimensions of your product. Recently, in one of our project, which we were building it for a client, we came across this scenario where the form factor of the hardware product, what we proposed in the initial architecture was pretty big, which the client and the customer of ours was not ready with. So hence, we were forced to rework on the entire, right, entire mechanical geometry of the product, including the sensors and the drivers, relays, and all the other components put together. So as a result, the form factor plays a very, very important role when you are building your IoT systems. Continuing further, when you are building any hardware for IoT applications, the design and the product companies need models supporting multiple different abstraction levels so that they can, right, compare the performance trade-offs versus the accuracy. For example, if Samsung is working on USB 4.0 chipset for their smartphones, then the USB 4.0, when it is interacting with any other external interface, the model of USB 4.0 should be available for Samsung. Then you may have a question in your mind that who is going to be providing this model of USB 4.0 for, right, Samsung? That may be coming from an IP development company, that may be coming from a, right, or product company who may give that model for as a ready-made available block. Then you may ask that why this model is very important. The reason is, even before completing our design and fabricating and releasing it into the market, we want to do the analysis. That means very much at the very infant stages of our design, if we want to do the analysis, then we need a model. And remember, there are large number of IP companies who basically work only on this. They basically work on the, right, IP models, they work on the communication models, okay, right, which people can use it for the very early, right, analysis of their designs. So with IoT becoming more and more complex, these models availability is also always a question, right? Not only that, even IBIS models, okay, right? Those are the models which goes into the PCB design. So even those model files for each and every component, each and every component which goes into your hardware, it is very, very important for you to ensure that you have those models. I'm sorry. So generally, when our students, when they work on their designs, they do come across these issues because of their sheer unawareness about the models availability. So as a faculty, my recommendation to all of you is that you please be aware about what type of a designs students are trying to explore, and please recommend them to check the availability of the models. For example, if they are working on a hardware part of the design for an IoT, right, then the tool which they use, they may be using Cadence, Arcad, or PSpice, or any other tool for the hardware design of the IoT application. It is very important, very much important for them to be aware about whether the models of the memory, models of the sensors, models of the, right, connectivity blocks are available for them, so that they can build the entire hardware without too many complications, and they can do the simulation of the entire hardware. Now, apart from that, once we build the hardware, it is important for us to ensure that we also have the support for the integration of the software components with the hardware. So as a result, whatever the tools and whatever the hardware, okay, right, which you are working with, you should have the support for the integrated capability. That means integration capability. That means your hardware models and your device drivers and your software components. You should be in a position to integrate all three of them seamlessly in a single development platform. Remember, when you are choosing any product for your laboratory support also, it may be a simulation tools, it may be a design tool. My recommendation to all of you is that please pay attention to these things. Anyway, you are going to invest your time and money in setting up of a tool to support your curriculum. But what is important is that whether the tool brings in the integration capability for you. That is very, very important. And second thing is that, right, whether that integration capability which the tool is bringing in, right, it is as per the industry requirements. So those are the things what you need to be familiar with. Then go to market. So improve your design reliability, reduce the cost and increase the productivity, and optimize your design using advanced circuits and system analysis. Today, right, if you are building a product or else if you are building a IoT solution from your end, you have powerful simulation tools, powerful modeling tools, and as well as even, right, the complete system level modeling and evaluation and emulation tools also. That means gone are the days where we used to just do the circuit simulation and model simulation and then immediately we used to jump into the hardware design. No, today we don't work like that. It is completely simulation driven design. That means if I have already identified what are the sensors which are going to be part of my IoT system, then the relays and the motors and everything, then I can very much pick up those models from the simulation environment. I can connect them in the simulation environment, and then not only simulating the hardware, whatever the board support packages, that means the firmware component which is needed to sandwich the hardware with the software, even that firmware pieces, drivers, device drivers is readily available to you. You may be working on a microcontroller from ST micro or else microcontroller from TI microcontroller, maybe from different vendors. So you will have all the device drivers and everything readily available to you. So you integrate that also. And on top of that, if you want to control, right, the data, right, which you are acquiring and the processing and all those things, with the help of your own custom software application, you customize that also. Now, in order to test your firmware and your software, you don't need to go for a, right, practical, and you don't need to go for a real hardware. That may sound a little bit vague for those of you are not familiar with the concepts of emulation and prototyping, but that is basically a facility which is available for the last 20 plus years. So that means without even having your hardware completely ready, you can check your firmware and hardware also. That means you can build your hardware in a simulation environment. You can bring your board support packages, device drivers and everything. You can bring your application, connect all of them end to end and test your environment, test your application and check your entire design. So then you may ask that what is the benefit of this? The benefit of this is that you can reduce your entire design life cycle, and by doing that you can release and you can come up with your product into the market at a quicker span of time. So if you are able to do that, then you may be able to make a better business for your products because you are able to bring your products into the market at a faster rate. Remember, this is what is happening in the industry today. If LG is releasing, right, a smart fan, then Samsung wants to, right, beat LG ahead of the game. Similarly, if, right, Bajaj Automotive is releasing a next version of the two-wheeler, then TVS wants to, right, TVS Motors wants to overcome, right, or want to be in the competition ahead. So that is how each one of these players, they are competing with each other. And remember, when you are building your hardware, or else when you are building your entire IoT system, you need to ensure that your design allows you to address this go-to-market requirements, in fact. So continuing further, there are more number of requirements. Need to operate in diverse operating conditions. Today, the smart Fitbit what you wear will be exposed to unprecedented moisture conditions from your body, and at the same time, right, heat variations. For example, if you are using a sensor, then if that sensor is is used for the automotive applications, then the temperature ranges are pretty wide. So you need to ensure that your devices and your designs, whatever you have created, they basically support diverse operating conditions. Then you may ask a question that how I can do that. For example, if you are building a hardware for IoT for automotive, then the temperature range may be from -70 degrees to plus 125 degrees centigrade. So when you are actually doing the simulation, you can ask your students to do the simulations for that diverse operating conditions. And even if they are able to do that for those wide temperature ranges, and when they are doing it for that wide temperature ranges, if the design allows for that, then they can actually simulate your students. Similarly, devices are exposed to unprecedented and highly varying external factors like thermal fluctuations, electrical noise, fluids, moistures, vibrations, and the shock. So as a result, today, when we are working on any IoT hardware system, we need to take care of power budgeting, we need to take care of time budgeting, we need to take care of thermal fluctuations, thermal analysis, and electrical noise, that is electromagnetic interference and electromagnetic compatibility, that is EMI EMC analysis, fluid and the moisture analysis, vibrations and the shock, which is on the mechanical analysis side. That is the reason I said today IoT as a technology, right? There is no need for the engineers and the researchers and right practicing engineers to feel that right only this part I'm going to manage. No, for example, the moment fluids comes into picture, moisture comes into picture, mechanical engineers support is very much needed for us. Similarly, vibrations and the shock. So as a result, when those kind of systems are built, those systems also going to be verified and also going to be subjected to simulations from the mechanical structure and mechanical right vibrations point of view also. So then we also need to have highly reliable operation of these systems for the entire life cycle. And today, for your information, when you are doing electronic circuit design and simulation, one of the very important aspect is that you also need to check for the reliability analysis, and that is where exactly you exposing your students to the industry standard tools really matters, because when they are building even a simple amplifier or a simple power supply block in their lab experimentation purposes or mini projects, they can also do the reliability analysis of those simple case studies with the help of the tools. So that is very much needed tomorrow when they work on IoT projects, IoT hardware, because the same reliability analysis can be a very good project option for them. And if an engineer knows how to do the reliability analysis, then that reliability analysis can be a very good job avenue opportunity for the young engineer, in fact. So continuing further, electronic system design for the IoT era at the very top level, as I mentioned earlier, right? It includes design and manufacturing and the fabrication of sensors, computing cores or controllers and the actuators and the connectivity chipsets. And the things which we need to take care is that from design and simulation perspective, the IoT enabled devices require the ability to design all the three blocks of the IoT. So whatever may be the tool or whatever may be the simulation environment which you may choose, that should support you to build all the 3 blocks seamlessly. Then simulate the complete system. Not only simulating the individual blocks, you should be able to simulate the entire hardware, and not only the hardware, you should be able to simulate the firmware and even device drivers, and as well as the software component also, everything in a package. So that is basically the kind of a requirement what your electronic system design is going through in the IoT era today, in fact. So with that note, okay, right? So I would like to know that, madam, how much more time I have? Hello? Hello?
Hello, sir.
Madam, am I audible?
Hello, sir. You are running out of time. No problem, sir. I can take 5 more minutes.
Okay, sure. So then, very quickly for all of you, that the IoT, what you are seeing today, okay, right? It has 4 layers. The layers includes the things, that is sensors and the actuators and the relays, then the nodes, right? And so basically these components forms the layer 1 of your IoT. Then the layer 2 is your gateway, where the gateway, as I mentioned earlier, it has the capacity to handle larger data traffic. That is the uniqueness of your gateway compared to your node, right? And then comes your cloud, which basically hosts all the data what you might have captured from the sensors and the nodes via the gateway, right? And the cloud, right, also integrated with one more important component, analytics. So as a result, these are the 4 constituent elements of IoT system today. So when you are building an IoT system, or else when you are analyzing an IoT system, please recommend your students to check that whether they want to be in layer 1, layer 2, layer 3, or layer 4. Traditionally, electronics and communication engineering students, they get lot of exposure on layer 1 and layer 2, whereas IT engineers, they get lot of exposure to layer 3 and layer 4. So my suggestion to all the researchers and students enthusiasts who are interested in pursuing a career in IoT as a technology, my recommendation would be that, right, to understand themselves that whether they are interested in focusing upon layer 1 and layer 2 or layer 3 and layer 4. If they are more hardware savvy, then I would recommend them to focus upon layer 1 and layer 2. If they are more savvy on IT, then they should focus upon layer 3 and layer 4 also, in fact. So because of the lack of time, okay, right, I'm stopping at this point, okay, right? So if you want to know more information about the different solutions what we bring from Entupal, so at Entupal we offer IoT platforms, okay, right, comprehensive development platforms for the right corporate and as well as automotive and even academia also, and IoT based solutions which includes machine learning and AI also. And we are proud to say that we are the one and only player who address all the 4 layers of the IoT in our solution framework, right? So as a part of the learning, we also providing programs, IoT workshops and IoT training come internship programs online and the classroom mode, and IoT full stack program also. So, and our programs are recognized by Electronic Sector Skill Council of India, NASCOM, and as well as IEEE also. So if you want to know more what we are offering, so you can visit our website and you can contact our team at the rate info@entupal.com, or right, even you can write to us at ask@entupal.com. We are happy to assist you in that direction. So with that note, I'm stopping now.
Thank you, sir, for
If you
such an
have any
enriching.
questions, you're most welcome.
Thank you, sir, for such an enriching and illuminating session on the design considerations in IoT on wearable devices. It was an elaborative session on how IoT could help in realizing a seamless connected world by penetrating into almost every life instances, such as daily life devices, business, public infrastructure, and healthcare, to name a few. The broad elucidation of wireless sensor networks, the key blocks in IoT system, electronic system design for IoT, and the bottlenecks faced in the designing phase was informative and useful too and ahead of the time. Thank you, sir, for the well-versed session. Now it's time for the interactive session. Participants, you can ask your queries by either typing them in the chat box or unmute your mic and ask directly to the speaker. I repeat, participants, you can ask your queries either by typing them in the chat box or unmute your mic and ask directly to the speaker. So there is a question from Namisha. Which type of computing node is used in wireless sensor networks and what are the research scopes in this area? Sir, there is a question from Namisha. Which type of computing node is used in wireless sensor networks and what are the research scopes in this area? Sir, Damodara sir, can you hear me?
Chippy, Sarah's got disconnected. We'll wait for some time. He'll connect again.
Okay, sir. Participants, you can ask your queries either by typing them in the chat box or unmute your mic and ask directly to the speaker. He'll be
Sorry,
connected
madam. I
shortly.
had a little bit of connectivity challenges. I'm back.
Okay, sir. So there is a question from Namisha. Which type of computing node is used in wireless sensor networks and what are the research scopes in this area?
So in case if we are dealing with data capacity of a few kilobytes up to few megabytes only, then it is the node MCU, okay, which is one of the very popular microcontroller based device, okay, which is used today. That is the first option, and second one is Arduino, okay, right, for that. If in case if you are looking at any node, okay, right, or computing node that has to manage a large traffic of data in terms of multimedia applications, then you need a microcontroller which has a lot of on-board memory and on-chip memory also. That is where exactly Raspberry Pi, okay, right, is becoming very, very powerful, okay, right, because it is a mini computer by itself, okay, right, which can give wide range of connectivity capability. So that is what is recommended by the global community across, right? And apart from that, even adding to all of these things, generally the one of the problem which any beginner or else entry level engineer who wants to work on IoT they face is that they don't want to build each and every component, each and every layer of the IoT on their own. They want to have ready-made components which they just want to stitch together and implement. For such type of users, my recommendation is that even they can start doing that with the help of, right, simple node MCU and Arduino. That is good enough. If in case if they are pretty comfortable with the things, then they can go for FPGA based. For example, in most of the institutions, they also will have Xilinx FPGAs boards. Even those FPGA boards, they can also use for the IoT applications. Now, answering to the second question that what kind of a right cost which they are going to incur, okay, right, in order to set up those things, my answer would be that these things don't cost much because all the resources are very much available in the campuses already, in fact. So hence I really don't recommend people to spend any money apart from the existing infrastructure which is available in the campuses itself. In fact.
Thank you, sir. So there is another question. Can we relate cognitive radio and IoT?
Oh yes, madam. It is very much possible. It is very much possible. So you have a couple of platforms which basically allows the end users to explore the applications related to IoT and cognitive radio. That means so both of them together. So I hope a couple of you. I mean, if you are not aware about the Z board, okay, from Xilinx. Zboard has a ARM Cortex A9 core, right, fabric within the FPGA, and that hardware also has an expansion connector, okay, FMC connector. Through that FMC connector, you can actually create your RF front end also, and you can connect your RF antennas, okay, for your LTE and 4G applications, 4G and applications also. And simultaneously, you can build your own cognitive radio and you can run your IoT applications associated with the cognitive radio. You can actually do that. And if in case, if you don't have Zboard, then please write to us. So we'll help you with, right, such type, how you can actually run such type of applications even with Raspberry Pi also, in fact. So or else at Tentupal, we have our own proprietary product, right? So which basically helps you to, right, explore both cognitive radio and as well as IoT related applications together. Okay, because today there is nothing like only one, I mean, a product for a specific applications. No, that barrier is completely getting shattered today, because if you have a product, that product you should be able to use it for multiple applications, in fact.
Okay, thank you, sir. So there is another question. In which microcontroller is best for adhesive patch type of products?
In adhesive patch type of products, madam, okay, right, we have microcontrollers, okay, right, from Intel, from ST Micro, from TI, okay, all of them, okay, which are very, very powerful. But the one which has come from Microchip, because it is Atmel who actually brought in that microcontrollers. Whatever you are seeing today in Arduino, it is all done by Atmel. And that is 89C52, okay, right, and all those series which are available today, it is all from Atmel. And today Atmel is owned by Microchip. So if you are working at patch kind of, that is wearable kind of a devices and solutions, if you are building, then my recommendation is that go for either Microchip microcontroller or go for ST Micro, because both of them, they are proven solutions. Whereas for the automotive and other players, you have microcontrollers from NXP, you have microcontrollers from TI also. But for the patch kind of a, right, applications, my recommendation would be that either go for Microchip or ST Micro. They are best suitable one, in fact.
Okay, thank you, sir. So we have another question. Can we make a database of sensor in IoT with Arduino? Any particular simulation software is available for this implementation?
Can you come again with that question, madam, please?
Yes, sir. Can we make a database of sensor in IoT with Arduino? And there is another question. Is there any particular simulation software available for this implementation?
So if in case, if there are multiple sensors which are part of your IoT, and if you want to manage, okay, right, how you want to control all of that with a single node MCU, the answer is no. Okay, the reason is the node MCUs like Arduino, okay, right, if you are not familiar with Arduino in detail, please be aware that Arduino can pump the data traffic only in the range of, right, few kilobytes and up to certain megabytes. But that data traffic volume may not be sufficient for you to manage, right, multiple sensors. And on top of that, if you want to create a database by acquiring so many different data terminals, you want to create a database, and if you want to control them, then definitely Arduino is not a recommended one for you, in fact. So if you want to do that, then go for Node MCU. Arduino is for very, very basic applications. Go for Node MCU, okay, which is coming from Expressify, okay, right? Expressify is a community, okay, right? Expressify chipsets are available today from ST, and they are also available from multiple vendors. So you go for either ST Micro, or else you go for either from NXP or TI or any other vendor. The most popular one is from Expressify. Okay, if you go to Expressify website, you will find that information. Or else in our product at Ntupal, we have such type of hardware also, right, where you have the capability of adding multiple sensors and acquiring the data from the multiple sensors and creating a database out of that, because we are bringing such type of capability. And another powerful advantage what we are bringing at Ntupal is that we are giving you a touch screen, even node also for you, which you probably today don't see from many other vendors. In fact, at Ntupal, we have a node MCU with a touch screen, right? So that if your students wants to control the database, right, with the help of a node MCU itself, it is possible. And for that, we are creating our own proprietary software, which is available from Ntupal, okay, right? And if you are more curious about that, then please drop a mail to us at info@ntupal.com or ask@ntupal.com. We'll share the details of our true IoT solutions from our end. Okay, right?
Okay, thank you so much, sir. So, participants, if you have any more queries, you can directly mail to the Entropal Technologies or his personal mail ID. So that was the end of the interactive session. Thank you, sir, for clarifying all the queries of the participants. And thank you, participants. Now I call upon Chinchu as Ragamaliga to propose the vote of thanks on behalf of the coordinators of this online FTP and all the participants to the speaker, Mr. Damodra MS, who found time despite his busy schedules to concoct an insightful presentation for all of us. Over to you, Chinchu.
Okay, am I audible?
Yes, you are audible.
Okay. Good morning. That was an interesting session by Mr. Damodra MS, Business Head, Entupal Technologies, Bengaluru, on IoT and wearable devices design considerations. And we had the first session of the 5-day online FDP on IoT for wearable devices, sponsored by AICTE ATAL, organized by the Department of Electronics Engineering, St. Kitts. So now I take this occasion to cause the profound gratitude for our speaker, Mr. Damodra MS, Business Head, Entupal Technologies, on behalf of all those who spent their valuable time for attending this session. Thank you, sir. Thank you so much for your valuable time.
Yeah, thanks, madam. Okay, all the very best for all the participants. Thank you.
Thank you, sir. Next, I would like to thank the organizers, Dr. Ansel K.A., Associate Professor and PG Coordinator, and Engineer Abraham K. Thomas, Assistant Professor, Department of Electronics and Communication Engineering, St. Kitts, for organizing such an event for us. Thank you, sir. Finally, I express my sincere gratitude to all those who attended this session with utmost interest. Thank you. The participants, please listen. The feedback link is shared in the chat box. So please fill up and submit it within 10 minutes after the session expired. Thank you.
Participants, I once again repeat, please fill the feedback form in 10 minutes, and also kindly note to use the same link for the next session. The next session will start from 11:30 a.m. Participants, please kindly note to use the same link for the next session also.